All right, this is a fun one. Sometimes it's fun to have these qualitative ones that don't involve doing formulas and math and dimensional analysis and such. We're just evaluating what we see here. So let's take it question by question. First, what's the ground state? And so we're looking at energy levels. Ground state is the where it's rests if it's not excited. So if it doesn't have some sort of energy boosted into it. And so we're looking at E for this one. Notice how they're labeled. It can be different. It can start with A, it can start with F. It can be different. With that, let's make sure there's not one higher up. Nope, starts with B. Okay, so we're looking at E for here. Next one, how many excited? So if E is the ground state, how many excited states are there? There's 1, 2, 3. So we got E is the ground, we got 3 excited. Now the next one is a little trickier. How many lines are an absorption line spectrum? Now, you've probably seen a problem where you had to maybe calculate the wavelength of a transition in a hydrogen atom. Now, that was one specific transition. So the same type of concept applies here. So we're going up with absorption. Make sure you check that question. Does it say absorption? Does it have, is it, or is it being, is it transitioning back down? So if we start at E, we can go all the way to B. We can go to C. We can go to D. There's 3 options. Now, if we start at D, we can go to B. We can go to C. And if we start at C, we can go to B. So 1, 2, 3, 4, 5, 6 possibilities there. Now, the next part is what's the shortest wavelength and what's the longest wavelength. Now, remember, when we talk about energy, shortest wavelength is highest energy. So that's going to be the longest arrow up here. So here we're looking at E to B. Now, longest wavelength would be the lowest energy. That's going to be the smallest gap, which it looks like to me is this C to B transition. So we're looking for the longest arrow you drew and the shortest arrow you drew or drew in your mind. Okay, so let's plug this in. We got E, we got 3, 6, E to B and C to B. So we're going to start with E, 3, that's 6. We got E to B, we got C to B. Oops. There we go. Okay, so again, pay attention to the verbiage. Is it talking about absorption, which is arrows going up? Or is it talking about the energy leaving when it comes back down? Remember, anytime an atom or an electron is hit by some sort of wavelength, so some sort of light electromagnetic energy, it's going to go from the ground state up when it absorbs, and then when it releases that, it's going to go back down. So pay attention to that verbiage in these questions. It's mostly going to show up in these transitions. You might have to go B to E and B to C instead of E to B and B to C if it's releasing that energy.